Yeah, we want to take a look closer at what SOHCAHTOA is and how to apply it. So this is SOHCAHTOA, SOHCAHTOA, and it has a very significant meaning. Let's say we have a triangle, a right triangle. We call it a right triangle because one of the angle is a right angle, which is 90 degrees. So if I call this as ABC, then the angle ABC is 90 degrees. And we are going to use this mnemonic SOHCAHTOA to define three basic trigonometric functions, which is sine, cosine, and tangent. So let's figure out sine first. Sine, S-I-N, theta is equal to opposite over hypotenuse. So that is what SO stands for. Sine theta is opposite of hypotenuse. And then cosine theta, we use mnemonic CAH. Cosine theta is adjacent over hypotenuse. And finally, tangent theta, which is denoted by TOA here. Tangent is equal to opposite over adjacent. So for this example, ABC, what is the value of sine theta? Sine theta is equal to opposite over hypotenuse, which is opposite is BC. So it's BC over hypotenuse, which is AC. Next, cosine theta is equal to adjacent over hypotenuse, that is equal to AB over AC. And finally, tangent theta. Tangent theta, which is denoted by TOA here. Tangent theta is opposite, which is BC, over adjacent, which is AB. So I want to bring two examples here, the real life example. The first one, let's bring up one right triangle. And I give this angle as theta. And the size of the opposite is 3 cm. Adjacent is 4 cm. So for a right triangle with 3 and 4 cm as opposite and adjacent, what do you think the length of the hypotenuse? Yes, you can use Pythagorean theorem to figure that out. Hypotenuse in this case is equal to 5 cm. So for this example, what is going to be the value of sine theta, cosine theta, and tangent theta? So let's pick up sine theta first. Sine theta, according to the mnemonic SO, equal to opposite over hypotenuse. So opposite is 3 cm. So let's put 3 there. Over hypotenuse, which is 5. So sine theta is equal to 3 over 5. Next, cosine. Cosine theta is equal to adjacent over hypotenuse. So adjacent is 4. And hypotenuse is 5. So cosine theta is equal to 4 over 5. And finally, tangent. Tangent theta is equal to opposite over adjacent. So tangent theta is equal to opposite is 3 over adjacent, which is 4. So 3 over 4. From these three trigonometric functions, we can find out the value of theta by using inverse trigonometric function on our calculator. So I bring up my calculator here. So we can find out theta equal to inverse sine of 3 over 5, theta equal to inverse cosine of 4 over 5, and theta equal to inverse tangent of 3 over 4. So let's use our calculator for the first inverse trigonometric function, which is inverse sine. So inverse sine, open bracket, 3 over 5, close bracket, that is equal to 36.87 degree. So we have figured out the value of theta using inverse sine. So let's try to find out the same value of theta using inverse cosine. So theta is equal to inverse cosine, bracket 4 over 5, close bracket. So that is equal to 36.87. As you can see, the value that we have got is the same. That's the reason is that the angle is the same. So if we find out inverse tangent of 3 over 4, we'll get the same value as well. So let's try it out. So inverse tangent, open bracket, 3 over 4, close bracket, that is equal to 36.87. As expected, the value will be the same. I want to bring up another example. This time, I'm going to show you the actual angle, which is 30 degree. And we know that sine of 30 degree is equal to 1/2. You can try to use your calculator. If you try to use your calculator, sin 30, you will get a value of 0.5. Well, 0.5 and 1/2 are the same number. So what information can we get from this figure? Sin 30 is 1/2. As we have already learned that definition of sine is opposite over hypotenuse. So the opposite is the numerator, which is equal to 1, and hypotenuse is the denominator, which is equal to 2. Then we can draw another triangle, right triangle, with the opposite of 1 unit and hypotenuse of 2 units. So we know now the value of opposite and hypotenuse. What about adjacent? Yes, we can use Pythagorean theorem again to find out the length of the adjacent. So let's call this triangle ABC. So adjacent AB is equal to square root of hypotenuse squared minus opposite squared. So that is 2 squared minus 1 squared, which is equal to square root of 4 minus 1, and finally that is equal to square root of 3. So the length of adjacent is square root of 3 units, and we'll leave the answer like that. Now we have figured out the length of opposite, adjacent, and hypotenuse. We can figure out the remaining trigonometric function for 30 degree. As we have already discussed before, sin 30 degree is equal to 1/2. And cosine 30 now is equal to adjacent over hypotenuse. We're going to use the length of adjacent as we have figured out using Pythagorean theorem. That is equal to square root of 3 over hypotenuse, which is 2. So cosine 30 degree is now square root of 3 over 2. And finally, tangent. Tangent of 30 degree, that is equal to opposite over adjacent. So the figure is 1 over square root of 3. But since denominator is a third function with square root, we want to change that to become a whole number. How do we do that? Well, we will multiply that by square root of 3 over square root of 3. So the answer will be square root of 3 over 3. Denominator now is a whole number. So that is how we use all the information available to us to figure out the value of certain trigonometric function of certain angles. So now I will urge you to do a lot of practices, because practice makes perfect. Once you have done enough practices, everything will be second nature to you. Thank you for your time and interest. Make sure you watch another video so that you can get more knowledge in mathematics. See ya!